Hi everybody, I'm Keith with BobsCNC. I'm here today with my best friend Bob.
Yeah.
And we are continuing with our G-Code 101.
Yeah.
Is that what it is?
Uh-huh.
We're at the very beginning if you can't tell.
Yep.
You talked about the coordinate system last time.
Yeah, it's been a while ago. We kind of got busy, so we're trying to keep up now. We're going to try to continue this G-Code 101 series and teach you how to write some G-Code by hand.
Now, one of the things I do is I use a CNC machine here in the shop, which is not to say I understand G-Code. I really I'm a machine operator. And I just turn it on and I home it and I make sure that our spoil boards are cut out correctly on it. But I got a project that I want to do in the shop. I've got a 4 by 8 foot shop table, and I've got a couple of routers that are set in that table right now, and I want to reconfigure that top. And I've asked Bob to help me write the G code so I can do all the inserts and I can set the routers into the table, and I have something that's really nice and clean looking. And he said before he'd do that, I'd have to understand G code. So that's why I'm here. So what do I got to understand?
Well, I guess first of all, we need to make sure that you understand the coordinate system, which I understand that you do, but if you don't, you might want to go back to that one video and look at coordinate systems. It's not that hard, it's just something that you need to understand, or what we're going to talk about in these next few series isn't going to make any sense at all. Now today's might be the exception, because I think today, or in this video, what we're going to discuss is really what is at the beginning of a G-code file. So the first thing that I have to tell you guys is a G-code file isn't something that is magic or anything. It really is XYZ coordinate systems with some feed rates and some other codes, which are normally letters like G, M, X, Y, or Z, that just tell things what the machine is going to do. So,
Can you give me an example? Could you write out what a typical start of a G code would look like?
yeah, and I think we're going to do that. We're going to actually cover the header file today, or the header part of the file. But what I want you to know is if you use WordPad, Notepad, or even Microsoft Word, or your favorite text editor, you can open up a G-code file and you will see all of these codes. And then once you understand what they are, you'll be able to just go ahead and you can actually take Notepad or WordPad and write you a file and then go run it. Now we want to check that, of course, with the G-code editor, but you don't need to. You wouldn't need to. You could actually just write it.
Okay.
So at the beginning of every G-code file, there's a few things that are going to be there that that you need to understand. And we're just going to go over 3 of them today. And this really pertains to simple hobby CNC machines. And we're not talking to the guys that run CNC or Mazaks, you know, at a industrial type shop like at John Deere. Okay? So we're talking really simple hobby CNC. So if you make a G-code file and you open it up in a text editor, you're likely to find these 3 things. And if you don't, they need to be there where things can happen that are really bad. And maybe we can discuss those. So let's go with the first one. So the first G-code line that you might find, and it may be in the second or third, but don't get confused. It's just somewhere in the top of the file. Is G90 or a G91. Now, honestly, most of the time it's going to be G90, and that'll make sense as we talk about it. So G90 is absolute coordinate system, right? Whereas G91 is incremental. So in the G90 world, if you see a G90, if it said X5, it's always 5. In the incremental mode, it could be 5, 10, 15.
You gotta make that English. I know
Okay.
you understand what it's talking about. It's kind of like apps.
Okay. All right, so let's just kind of do it maybe with a coordinate system. So let's say that in our G-code file, we have a G90, okay? And then we say that X is at 0, and then the next line is X1, X1, X1. Sorry, G90.
Yeah.
Okay? So, if I ran this G-code file, I would tell the machine that it's at 0, and then I would say X1. I guess we should have a 1. We'll make this 1, okay? So I would say X0, it would read the first line, and it would say, I'm already there.
Yep.
It would read the second line and say, X1. It would go over here to X1.
Right.
It would read the third line, it would say X1.
You're there.
I'm already there, exactly. And we need the next X1, it's already there. It is not moving, it is absolute coordinate system. Now, all I do now is I take and I say this is G91. We start again. So we'll start at 0. It goes to the first line. It says it's 0, 0, incrementing 0. It's still there. And it says X1. Reads the next line. It says X1. Doesn't stay now. It goes one more. X1. It goes one more.
Okay.
So that's incrementing values. So
What is the value of that?
well, in writing G code by hand, I don't really know that there would be a value of it except for, let's say that you had a board that you wanted to cut out a hole starting at 1 inch and then you wanted to cut 1.67824 hole in increments, right? Well, I don't want to do the math, right? I don't want to go, okay, I got the first one, I can type that number.
Okay.
But now I got, okay, times 2, right? Oh, well, that's about, and you get, so if you put it in incremental mode, now you can just keep on
It just
typing that number.
automatically adds it and moves.
Yeah, so let's say, yeah, let's just do that so that we can see it. Where is our ratio? There it is.
Here you go.
So let's just say that we started, our first one, you know, we started at 0 because we're, you know, conscientious of making sure that we're at the right spot. So we want to go 0.6724, right? 0.6724. We could just keep typing this in, right? And we would go over 0.6724, another we would add and add. If we, of course, were in the G90 mode,
It's not
it
doing
would
anything.
just go to that one
Okay.
spot.
All right.
So you can see if you were making a, if I erase this here so I have some room,
Cribbage board?
yeah, a cribbage board would be a good example of that. If I had this block that I wanted to make incremental holes, then yeah, G91 would really help me out if this was 0.67, whatever.
Or
it was.
whatever.
Yeah.
Okay, that makes sense.
Now, obviously, if it was 1 inch, it would be easy because I could go 1, 2, 3, 4. But incremental works really nice.
So if
we're
I'm
adding
running a
up-
G code file and I'm getting, I don't know how, oh gosh, I wish I could think of how to say it. It's not doing what I want it to do. And I notice there's a G91, which I generally would never have in something that I'm going to do. That's what I need to look for.
Yeah, you
in
can
the code.
change it to a G90 and get absolute votes. Or
Okay.
it could be the opposite. If you're thinking that it should keep on counting up and it's not, go look for the G91.
All right, so
Okay.
G90, G91.
You gotta do something with this eraser. All right, so that was pretty easy.
Give it to me.
The next one, the next one's pretty simple too. It's just that it gets complicated in reality, but not for our machines. So the next one is there's a G17, a G18, and a G19. What are these? This really defines the plane that you're cutting in. The good news is most hobby machines are XYZ machines, and they are cutting in the XY plane. So you could actually eliminate this from your G-code file, but you're going to see G17.
Okay.
If you saw G18, it would actually be in the ZX plane, which is not your coordinate system. Your Z now would actually have, your spindle would need to be rotated sideways, or your machine configuration would
So
be
unless
different.
I'm milling something,
Yeah.
okay.
Unless you're an industrial,
This is the only thing I gotta care about,
you just, if
G17.
you see a G17,
I'm making my life easy.
okay, there you go, absolutely.
Okay.
So really that means you're cutting in the XY plane. If it's there, leave it there. Actually, if you're a good G-code writer, you would put it in there to make sure that the next person that reads your file understands that you're in the XY plane.
All right.
So there we go, G17, you may find that. If not, you may want to put it in there if you're writing a G-code by hand.
Gotcha.
So the next one that we get is G20 and G21. This defines units. It's either inches or millimeters. You cannot define meters, you cannot define feet, miles. G20, G21. You get inches or millimeters. You've got to decide which one you want to do. However, you might note that if it's missing, different programs default to different units. Universal G-Code Center defaults to millimeters. If it's missing, it will be done in millimeters. So if your work is actually 25.4 times smaller than it should be, you probably know.
Okay.
Because 1 inch,
So if this is not in your code, if you want to do something inches, it's not in your code, the
Universal G-code sender will do it in millimeters. So if you wrote a block that was 1 inch by 1 inch by 1 inch and you did a square, and then you ran it without the G20 in there, or the G21, it would default to the G21, and you would go 1 millimeter over, 1 millimeter over, 1 millimeter over.
Okay.
And a millimeter is about 40 thousandths of an inch, so it would be really small.
So the basic three I'm going to see are G90, G17, and G20, or 21.
Or 21, depending on what units you're in.
Okay, now is there an advantage to working, you know, other than the fact that we live in the U.S. and we've grown up with inches and feet and whatever, is there any advantage for accuracy doing calculations to use millimeters versus inches?
So as far as accuracy, none. I mean, it's a number. Whether it's millimeters or not, it's just converted one to the other. However, for easy to read, it may actually be easier to design in millimeters. Most companies today, I shouldn't say most because I don't know. The companies that I've worked for today actually use millimeters to design in.
Okay.
Right? I use millimeters to design in. You can do it in inches.
But most of the cabinet work I've ever done, I've always done it in inches. I'm cutting it on a table saw and whatever. So I can work in inches, it's not a problem. I just have to make sure it's G20.
Yeah.
Okay. Cool.
Okay, so if we were to write a G-code file, you would want to make sure that those three commands were at the top. If you're reading a G-code file, somebody else's, you would want to see that, you know, what it's actually doing. Those three commands should be in the top somewhere.
Now, do I have to designate G? Can I put G90, 17, 20?
On the same line?
How do I write it? Yeah.
Actually, I like to keep mine separated, but you can put them all on the same line. It's easier to read if you put each code on an individual line. And as we'll see later when we start writing movement commands to the G0, G1, it absolutely makes a huge difference on what line they're on because it's going to operate those all at the same time. So yes, you can put these three on the same line. I would suggest that you do not. And I would also suggest if you're writing a G-code by hand, you can actually put certain symbols so that you can write comments after it. So you can,
pardon me, if I'm typing a text thing, like in whatever, I would just put G90, return, G17, return, G20, return.
absolutely.
Okay.
And if you wanted your reader to be able to understand, you would say G90, and then I can't remember what it is. I should know this, but I think it's brackets. You could say ABS, or you could actually spell out absolute, and it would skip this part because it's a comment.
Okay.
So you could say G17, and then you could put in there XY plane, and then you could say G20, and then put in inches.
And
then the person would understand what that meant.
Okay. All right.
Not necessary, but it's good to comment your code.
All right.
All right, guys, so that really kind of covers the header file. I think that's probably enough in this video. You think?
Robert, thank you.
All right. So, till next time.
See ya.